Welcome. In this video, we are going to determine whether the series converges or diverges using the integral test. Of course, before we continue, or before we begin, we have to ask ourselves, is this function, that is 1 over the square root of 2x minus 5, is this 1 continuous, 2 positive, and 3 decreasing? Well, let's start with continuity. The only continuity or discontinuity here exists when 2x minus 5 is less than or equal to 0. And that only occurs when x is less than or equal to 5 halves, which is just 2.5. And you notice we start here at 3. So on 3 to infinity, f is continuous. I'm going to use a little shortcut here and just write a C with that degree symbol. So f is continuous. What about positive? Well, this function f is not at all defined for, values smaller than 2.5, as we saw in our previous part. So every single value we put in, 3 and up, is going to keep this positive. In fact, the smallest possible output we could get here is 1, since that would come from plugging in 3 to get 1 over the square root of 6 minus 5, which just works out to be 1. So on 3 to infinity, f is definitely greater than 0. What about decreasing? Well, again, this part is really just calc 1, and I'm going to give you the derivative just to keep this video a bit shorter. So f prime of x, that's equal to negative 1 over 2x minus 5 to the 3 halves power. And then let's just think about where this function is defined. Clearly, the derivative can't be defined where the original function is not defined. So since our original function has to be, x greater than 5 halves to be defined, that is 2.5, and we're beginning at 3, we know that the smallest value we can put in here is 3. And again, this denominator will always be positive. This numerator will always be negative. So this is certainly less than 0 for x greater than or equal to 3. So we verified that we're continuous, positive, and decreasing. So now we can apply the integral test. So that's the integral from 3 to infinity of 1 over 2x minus 5 dx. Now, before we go on with our integration, we should take care of our notation. That is, replace this upper infinity value with a t, and we want the limit as t approaches infinity, and our integral is unchanged. Now, you can figure this out with a substitution, so please pause your video now and figure out this antiderivative using a substitution. All right, this is what you should have gotten on your integral. And so now we can evaluate the endpoints. And we have 2t minus 5 minus the square root of 1. So I'm going to move this finite value out to the front. So this is negative 1 plus the limit as t approaches infinity of the square root of 2t minus 5. And I didn't have to do that, but hopefully this helps you see that we have something finite here and we have something infinite here. So this entire integral is infinity. The integral diverges, so the series must diverge as well. I hope this video has been helpful.